All right, let's talk about one of the sneakiest and honestly one of the most common vulnerabilities out there. OWASP's API Security #5, Broken Function Level Authorization. We're going to call it BFLA. This is the kind of flaw that can turn any regular user into a full-blown admin with just one simple request. It's like leaving the master key right under the doormat.
Okay, so picture this. You've got this cool new app, and it's invite-only. You know, it feels exclusive, it feels secure. You're building this little trusted community right from the get-go. But that very feeling of security, that's exactly what an attacker is counting on.
So, you get your invite, you sign up, and you start poking around. And if you're a little bit curious, you might pop open your browser's developer tools to see what's happening under the hood. You look at the API call for your profile, and there it is, right there in the data, a little line that says role equals user. Now, to most people, that means nothing. But to an attacker, that's a huge flashing neon sign. It's an invitation to try something.
And this is where the hacker brain really switches on. They think, okay, if the app can show me my invitation details, there's got to be an endpoint somewhere that creates them, right? Modern APIs love predictable patterns. If there's a get/API/invites, it's a pretty safe bet there's a post/API/invites hiding somewhere. And now, all they have to do is test that theory.
So they craft that post request. They fire up a tool like Postman or Burp Suite, copy the data structure they just saw, but they change one tiny little thing. That role field, they just flip it from user to admin. It's a simple, audacious move, and it's all based on the hope that the server isn't actually checking who is asking.
And it works. The API, because it completely failed to check if this normal user should be allowed to create admin invites, just goes ahead and processes the request. A second later, an email hits their inbox with an invitation link for a brand new admin account. And just like that, they've gone from zero to hero. They have the keys to the entire kingdom.
That scenario, which is terrifyingly simple and happens all the time, is the perfect example of broken function level authorization. So let's get formal for a second and break down what this vulnerability actually is and, why it's so incredibly dangerous.
So here's the deal. BFLA is a breakdown in authorization. You've got two key concepts here, authentication and authorization. Authentication is proving who you are. You logged in with your password, great. The system knows it's you. But authorization is all about what you're allowed to do. BFLA is what happens when the API says, yep, this is a valid user, but then completely forgets to ask, but is this user allowed to delete the entire database? It misses that second crucial step.
I love this analogy because it just clicks. Think about it. Your login is the key card that gets you into the front door of the building. That's authentication. You're in. But BFLA is like finding out that the key to the janitor's closet also happens to unlock the CEO's office, the server room, and the company's vault. The system just isn't checking for different levels of access. One key opens everything.
Now, it is super important not to get BFLA confused with its very famous cousin, Broken Object Level Authorization, or BOLA, which is OWASP API #1. They sound similar, but they're different beasts. BOLA is all about accessing data you shouldn't, like changing a user ID in the URL to see someone else's private messages. BFLA is about executing functions you shouldn't, like a regular user calling the promote user to admin function. So here's the easy way to remember it. BOLA is about what data you can see, and BFLA is about what actions you can do.
And let's be crystal clear, this is not a minor bug. OWASP gives BFLA a high-severity risk rating of 8.0. Why? Well, because it's usually pretty easy to exploit. And the impact is often catastrophic. We're talking full system compromise, data breaches, you name it. This is a big one.
So, how do the bad guys actually find these unlocked doors? Well, they're not just randomly guessing. They have a few common, pretty systematic techniques they use to poke and prod your API, looking for these exact weaknesses.
One of the most common methods is called forced browsing. It's pretty much exactly what it sounds like. First, an attacker will use tools to map out every single API endpoint they can find. Then, they'll just look for juicy-sounding names, anything with /admin or /management or /system in it. Finally, while they're logged in as a totally normal user, they'll just try to visit those URLs directly. If they get a successful response instead of a big 403 forbidden error, bingo, they've found a BFLA vulnerability.
But that's not the only trick in their playbook. There's also HTTP method tampering. Maybe you protected the GET request for a resource, but did you remember to protect POST, PUT, or DELETE on that same resource? They'll try all of them. And of course, there's parameter tampering, just like we saw in our story. Sometimes they can even mess with the data inside a JWT token to change their own permissions if it's not signed properly.
Okay, that's the scary part. We've seen how attackers get in. The good news? This is 100% preventable. So let's talk about the defense. Let's talk about how we bolt these doors shut for good.
The entire foundation of preventing BFLA comes down to one core principle: deny by default. This means your system's default answer to "can this user do this thing?" should always be no. Always. Access should never be an accident. You have to build specific explicit rules that say, yes, users in the admin role are allowed to access this function. If a rule doesn't exist, the answer is no, period.
And you have to start thinking about this from day one, right in the design phase. First, centralize your authorization logic. Don't have little permission checks scattered all over your code. Have one single, solid, well-tested module that everything has to go through. Second, get granular with your roles. Don't just have user and admin. Think about editor, viewer, moderator, and give each one only the permissions it absolutely needs. And finally, architecturally separate your APIs. Your admin functions should live on a completely different endpoint, maybe something like api.example.com/admin, to make them easier to lock down and monitor.
Now, if you remember one thing from this entire explainer, please let it be this: you can never, ever trust the client. Ever. Just because you hid the delete button in your fancy JavaScript front end doesn't mean the endpoint is secure. An attacker doesn't care about your UI. They'll talk directly to your API. Every single permission check for every single request must happen on the server using a trusted source of information like a server-side session or a securely signed token.
All right, let's pull all this together into an actionable plan. These are the key things that you and your team need to be thinking about to shield your apps from broken function-level authorization.
So here's your final checklist. 1. All checks happen on the server, no exceptions. 2. Deny by default should be your mantra. 3. Centralize your authorization code so it's consistent and easy to audit. 4. Test this stuff. Write actual automated tests for your security controls just like you would for any other feature. And finally, 5. Log and monitor everything. A sudden spike in 403 forbidden errors could be the smoke that tells you there's a fire. It could be your first and only warning that someone is trying to break in.
So I'll leave you with this. I want you to go back and really think about your own systems. Are you absolutely positive that every single one of your admin functions is protected by strong server-side checks? Or is there even a small chance that somewhere, deep in your API, you might have left one of those doors unlocked?